Today we are starting new class of class 12 chemistry coordination compounds, and today's topic is double salts and coordination compounds. So first we have to know what are double salts. Just have an example first. Potassium sulfate plus aluminium sulfate plus 24 water is forming K2SO4 dot Al2SO4 whole 3 dot 24H2. Now this is the product. If we this is obviously solid. If we pour it into water and dissolve it, then if identification test is done, then the presence of K plus, presence of sulfate, presence of aluminium and water, obviously there are. So these are the three ions. These are the three ions present. These two are cations and one anions are present. So there is no individual presence of potassium sulfate or aluminium sulfate. There is presence of the consisting anions and cations. So there is no individual presence of any entity or any moiety, just only ions. So this is known as double salts. So we can actually conclude when the solutions of two or more salts are mixed in the simple molecular ratios and then evaporated crystals of new compounds separated out. These new compounds are called addition and molecular compounds, which includes double salts, and these are the salts that lose their identity in solution and breaks down into simple ions. These are called double salts. Okay. Just we have seen that we are doing a mixture of potassium sulfate and aluminium sulfate, and this mixture done in water and then it is evaporated. Then there is a solid mass and a solid salt we have gained, which includes both potassium sulfate and aluminium sulfate, and this salt does not retain its entity in the solution if next prepared, and if identification test is done in the solution, then the consisting cations or anions are present, not any moiety. So this product, this is actually an alum, is a double salt. So now what is coordination compounds? These are the compounds when one or two salts are being mixed and then evaporated, such as we can say that we can get an example of nickel chloride, and then we are dissolving it in ammonia aqueous, and there is formation of a new compound or addition compound. This, if it is dissolved in water, if it is done as solution of water, then this moiety is present in the solution. So if an identification test or a test is done to identify, then there is a presence of this moiety and this ion, that is this is a new moiety, right, present in the solution, and chloride ion. There is no presence of constituting ions, that is Ni2 plus. There is no presence of Ni2 plus ion, no there presence of Ni bare nickel 2 plus ions. So this is a new moiety, this is a new entity present in the solution. So this type of salts retain their moiety, their presence in the solution. They does not dissociate in constituting ions. These are called coordination compounds. So we can conclude that these are the molecular or additional compounds containing by evaporating these solutions when two compounds in molar proportions which retain their identities even when dissolved, right? Even when dissolved in water or any other solvent and having properties completely different from those of the constituents are called complex salts or coordination compounds, right? And the branch of inorganic chemistry which deals with the study of coordination compounds are called coordination chemistry. So what is coordination chemistry? This is the study of coordination compounds. Okay. So what are the difference between a double salt and coordination compound? So if we just have the difference, we will have, right, on the first point, these salts only first is existence, right? Existence, on the basis of existence we can, the first point, we can conclude this is the thing that only remains in solid, but coordination compounds can retain its entity in solution also. Okay. Second is the proportion. This is to be equimolar, but this can be may or may not be equimolar. Equimolars means that the two or more components of same number of moles we have to add to prepare the solution, to prepare the salt. And the third one, that is the most unique one, that is the identity. This cannot retain identity in solution, but this can retain its identity, right? This is entirely different from the constituent compounds, so it can retain its identity. The next one is valency. Double cells constituent elements show their normal valencies that we can see from octet rule or duplet rule, but coordination compounds will show a new type of valency, that is secondary valency. This is a new type of valency we will see, and the second, the normal valency, that is a primary valency, both. Okay. So we want to know the example. Just see the previous example of nickel hexaamine chloride. This is a complex. So here the secondary valency of nickel is 6 ammonia molecular entity is attached with nickel, and primary valency is 2, that is nickel 2 plus or nickel 2. We put the valency, primary valency in the Roman, not in 2 plus, because this is a new type of what we can say that new type of bonding is present, that is coordinate bonding. So there is a plus 2 effect, that plus 2 ions. So the primary valency of nickel is plus 2 or plus 2 or 2, and the secondary valency is 6. So this is the difference on the basis of valency. And the last one is, these are compounds which, this is the type of, on the basis of bonding, this is the type of compounds which are not involved in coordinate bond. But here we can see coordinate bonding. This is a new type of bonding present in this type of complexes. So today, whatever we have learned, we can do a flowchart to remember all clear. That is the addition or molecular compounds are divided in two parts, or two types rather. First one is double salts that cannot retain its identity. Double salts that cannot retain its identity in solution. Just an example of potassium sulfate, aluminium sulfate, 24H2. These are the crystal water. So these are salt. This is the general alum. Okay. And the next type is coordination compounds. This can retain its identity, or new identity is formed in the solution. We can see new type of moiety is present, and this type of compounds are actually of three types. First one is cationic complexes. Just an example that this complex ion carries a net positive charge, right? That we have seen this one on the previous example, right? We have seen it, this type of, or rather another one, chromium xamine 3 plus. Sorry, this is the complex. Another one is anionic complexes. Example we can see that the net negative charge it is carrying, right? This is FeCN whole 6 4 minus, that is known as ferrocyanide ion. Another one example is AgCN2 minus, this is known as argentocyanide. This is known as the electrolyte for the electrolysis of argentum, that is silver, to make a silver coating on any type of things, right, any substance. And the last one is known as neutral or molecular complexes. And we have an example of just as nickel carbonyl NiCO whole 4. There is no net charge on the coordination moiety. Okay, just as COCl3 NH3 whole 3. This type of complexes are present, which does not contain any net charge. Okay, these are the neutral molecular complexes. So whatever today we have read, that is, we have read the additional molecular compounds which actually formed by involving two or more salts and then making a solution and then evaporating it and getting a new type of solid. This conclude two types These include two types, double salts and coordination compounds. Double salts are the salts which cannot retain their identity in the solution if that solid is being make a solution in water or any other solvent that cannot retain its identity, and we can see that the taste of identification gives positive result for K plus, that is a potassium ion sulfate, and Al3 plus aluminium. No other new entity will form, but in this type there are the new entities forming in the solution, and the which are actually different in properties from the constituent constituent salts. And this type of this type and actually classified in three subtypes. These are cationic, anionic, and neutral. Cationic complex, the coordination moiety actually bears a net positive charge. Anionic complex coordination moiety bears a negative charge. And neutral or molecular complex, these are the complex which are actually bearing no net positive, that is a zero charge. So this is double salt which will form ions in solution, and both cationic and anionic complex which are obviously bearing some positive charges actually soluble in solution. So double salt and cationic and anionic complexes are actually soluble in water because they are forming ions, right? This is the reason that they are forming ions. But molecular or neutral complexes are actually insoluble in water because water moiety, how water involves how dissolved water can dissolve any other salts, because water dissolved forming a sheet around a ion. Here I'm showing a cation. So sheet then is dissolving in the intermolecular space and then dissolving it. So there the formation of negative charge or positive charge is important because around this there the water molecules having a little bit of polar character will just make an envelope or sheet. So it is important to make a ion to be dissolved in water. Okay, water is a polar solvent, so insoluble in water, that's the neutral complexes are insoluble in water. Okay, so these are the things we have actually gone through. So the things, the difference between double salts and complex compounds, we have also read it. Okay, so these are the things we have read today. Our new video will be on the terms of coordination compounds and as well as on the denticity of ligands. If you like the video, please share and subscribe the channel, and for getting a new update and new videos, please subscribe our channel. Thank you.